videos and live streams, which are accessible by the user by subscribing. So subscribed user will earn an NFT as proof of their contribution towards the creator. Next. Okay, so why do we need to have this platform on Web3? So the first reason is because of its immediate payout. So in Web2, creators cannot earn immediate payout. But in Web3, creator can directly receive their money once a user has subscribed to their platform. So for the second reason is we use NFT as proof. So user will earn exclusive NFT as proof for every subscription they do, where the NFT will contain details regarding the subscription, and only NFT holders can access the content. The NFT rewarding system will give the user sense of exclusivity and give them the feeling that they are a part of the creators organization, which will encourage them more to keep on subscribing. User can transact their expired NFT in the marketplace as well. And then the third reason is the business opportunity. So the platform will receive money as royalty for every NFT sold, whether by subscription or secondary market transaction. Next. So now we're gonna move on to the monetization. So once a user has subscribed, they will mint an NFT. So the primary sale revenue we estimated around 80% will go to the content creator, and then 20% of the sales will go to the platform as royalty. And then the platform will also receive royalty from secondary sales on the market. Next. Okay, now why should this platform be deployed in L2? So L2, there are some example of L2 now, such as Scroll, Stocknet, and other L2. So the first reason is because of its cost efficiency. So L2 provides a lower gas fee, which is suitable for high transaction volume. And then the second reason is scalability, where L2 is able to handle high volume of user at the same time. And then the third reason is efficiency, where L2 is able to provide a faster and efficient transaction for better user experience. Now we're gonna move on to the product demo.
Okay, so this is our landing page. Okay, so this is the initial amount of the wallet for the content creator and the platform at the beginning, before the transaction happened. Okay, now we click Mr. Beast profile. It will redirect us to the Mr. Beast page, but all the contents are still locked. So we connect our wallet. The wallet is connected, but we can connect the NFT because we still don't have the NFT. So we need to mint the NFT. Okay, when the mint is completed, you can see your NFT on the OpenSea testnet. Now with the NFT, you can connect your NFT and unlock Mr. Beast's full content. Okay, so now this is the proof that the monetization worked because the platform and the content creator received the money. Okay, so that's it for our demo.
All right. Do you have any more last okay, are you done? Like 100% done?
So for the further improvement, we would like to implement live streaming.
Oh yeah. Thank you. It's okay. Live streaming. What else are you going? Okay, what else are you going? What else are you going to improve on?
We are going to use live stream using live peer, and then from the streaming we can donate the streamer using crypto.
All right. Thank you so much. Great project. Thank you. And congratulations for the presentation. I mean, for building the project. I got a quick question. So I'm a bit confused. When it comes to NFT, does the content creator mint their own NFT? That means they're issuing their own NFT and then they sell it.
Yeah, it's like that.
Got you.
So are you familiar with Substack? But is it kind of like a blog? Basically, if I can describe it in a simple way, is it kind of like a blog that someone can have, and then they can have a free version, and if you want to have like a paid version, then you have to buy an NFT or mint an NFT to be able to access that. So would my
But it is not free.
yeah, so you have to pay to be able to read a particular article. So I guess a very simple question would be like, if there's something like Substack out there already, where payment is easy, you'd have to know how to set up a wallet, and you pay one time, you subscribe for a year, rather than have to buy an NFT each time. It feels like that will be a lot easier as a user experience, both for the content creator and the reader. So how do you, what is the advantage of doing all this Web3 stuff versus that Web2 version that we have now?
Okay, so for the advantage, there are already some existing platform like this in the Web2, right? So the advantage of putting this kind of platform on the Web3, the first thing is that, as mentioned before, in the Web3, the money will, once a user subscribes to the content creator, the money will directly go to the content creator's wallet, which is already cut by the royalty as well to our platform. So every subscription is like a direct transaction, direct transfer to the content creator, while on the Web2, the money will usually be like they will get a monthly payment based on the amount of subscription. And then the second part is that we offers NFT as like a additional reward for the subscriber, where the NFT will act as a like a give them like some sort of exclusivity and achievement that they have subscribed to this content creator, that they have support this content creator. And then the another additional thing is that this NFT, once expired, they can be sold on the secondary market as well.
All right. I think that's all. Thank you so much for a good job. Congratulations. Thank you so much, and do remember to get your swags on over there. Thank you, team ContentHQ. Right now, next we have SafeHome, and after that we have Proof of Age. So Proof of Age, can you please stand by on the left of the stage?
Test. Hi, everyone. Hope everyone got a good sleep. Judges, fellow participants, today I'd like to present to you our zero-knowledge solution for residential communities called SafeHome. Our objective with this hack is to solve the issue of privacy leaks when using residential community apps, which are common in condominiums and service apartments. So I got to this idea because recently I just purchased a condominium. You have to sign up for the Jaga app, you have to join the WhatsApp group and things like that. Suddenly you're doxxed. Your phone number, your name, maybe even your address will be leaked. So this is, I think, a very personal challenge for me, and I think other people face the same. Because as our population grows, people are moving into higher density buildings where privacy is in short supply. And there are many ways your information can be leaked. In addition to, the aforementioned examples, your daily routine, going to work, what time you go, what time you come back, which exit you take. This is all recorded on your access card. Someone with access to those logs could predict your movement, could predict your daily schedule, your usage of facilities, especially those that require scheduling, can let someone know where you'll be ahead of time. And an attacker won't hesitate to use it against you for the right price. So our solution is SafeHome. Oh, sorry, a bit lack of sleep here. So the examples given, which I already talked about. So here's our solution. Using SafeHome, the user will be able to register as a homeowner, book facilities, and also vote on important topics in the community while remaining safe from prying eyes. And I'll go into the user flow. This is our ideal flow for user registration. Through the SafeHome app, users register their details, which are hashed on their local device. And this information enables the app to generate a proof, and the proof is transmitted to the verifier, and then it can be verified using a circuit with zero knowledge, meaning that the actual data is never transmitted, just the proof. And if the proof is valid, you have now gained access to your owner privileges. And in the example that we built for this hackathon, it's highly simplified. We did attempt to do a proper ZK circuit, but the implementation was quite challenging. So instead, we use a mathematical method of determining zero knowledge proof. So for example, let's say we have two towers in this residence, and you want to allow Tower A residents to only go to Tower A, and Tower B residents to only go to Tower B. And then we split all of the units in these two towers into natural numbers. So 1, 2, 3, 4, 5, and so on. And so we can split into two groups where 1, 3, 5, the odd numbers are all in Tower A, and all the even numbers are in Tower B. And in this way, hold on 1 second. I'll just go through the flow real quick, which is that by just connecting wallet and entering the unit number, but not submitting the actual unit number, we can check divisibility of the unit number by 2. And therefore, if it's not divisible, it goes to Tower A. If it's divisible by 2, it goes to Tower B. And this is a way of knowing which tower to allow access to without knowing the actual unit number. So this is our overly simplified zero knowledge concept. And then now we'll do the demo. This is my teammate Han, and this is ZK. it's your name, right? Actual name. Yeah. So ZK is actually our ZK guy, so it matches up.
Hi, I'm Han. Good to be here. And I'll just walk you through some a quick demo of how this app works. So this is the landing page, and we try to think of user friendliness. So it's in a mobile app, web app, which is in a mobile frame. And this is the landing page, and the rest of it's sort of like an app to log into the first page. And to log in, to access to the rest of the functions, you have to connect wallet. And then this is the part where you key in your sort of security word. And then this is the QR code that pops up to access to the facilities or into your compound. And then these are this is community voting. And then this is another one, which is, okay, the booking and all. And thank you very much. Oh, 30 seconds, all right. Right, so, and also we are happy to be able to deploy and scroll. So, and we notice significantly faster transactions. Yep.
Yes, so all of these functions, we are see all of these functions, we are using, trying to use ZK proofs using the QR code. All right. Cool.
Okay, thank you so much, Team SafeHome. Congratulations on your project, great one. I personally have faced a lot of privacy issues when purchasing an apartment. I got like so many spam mails, so that's a very good idea. So what are the challenges that you face especially when writing a circuit?
Oh God, yeah. So I think I'll pass this on to ZK.
I found that the circuit cannot using divides. Like example, the example just now show is divisible by 2, but actually in the circuit it's not easy to do so, and I cannot figure out how. So I actually try to use a boilerplate circuit. It's a recover public address from a signature to ensure that the address have their own ownership. But then I still cannot figure out how to integrate into front end. So yeah, everything is still mock out in this phase. Yeah, a lot of problem face.
Thank you. I bet it's a great learning experience for you guys. Well, I guess no one has questions. But yeah. Crystal clear, I guess. Well, we have like 3 minutes. Would you mind going through like the other extended use cases?
Yes, we have a few. This is just the facility entry. So the idea is that, like, how do you book a facility and prevent other people from booking the same slot without showing a log? Because if there's a log, someone can determine ahead of time that, oh, hey, you're going to have your daughter's birthday party on this day. They can call you, they can email you and say, oh, there's a problem with your booking. We need some information from you, and that's how they socially engineer. So by using a ZK code, which is only a ZK proof, which is only valid during that time slot, you prevent other users from accessing it, but at the same time without having a central log. And this is building access control. Since ZK is a Boolean result, is true or false, you can stack these to just give building control, elevator control, unit control, even unit door control, just by stacking the true-false challenges. And community voting. This one is actually pretty interesting. While researching this, I found that Vitalik actually made a solution to voting called MACI.
Macy?
Yeah, Macy, that's the one. Something anti-collusion.
Yes, we do have that video on ETHKL YouTube to check them out.
Yeah, so I thought it was a very interesting solution, and if we had more time, we would have tried to implement that. Here are the extended use cases. So first off, I think this can be brought into the commercial lots as well, commercial offices, to prevent the tracking of executives. And then this can prevent social engineering that takes advantage of insiders in corporate security. And also in combination with ZK Finance, we can allow totally trustless and private home ownership, transfer of property without names or address or anything involved, which, like you say, once you put your phone number up there, once you request for a loan, your phone number is in the registry, or everyone's calling you all the time.
Thank you so much for the explanation. Thank you so much for the presentation. I think there are a lot of ZK use cases over here, which we can probably explore as a community, I guess. I'm looking at the community, giving them pressure. Yeah, I think that's all. That's all for us, I guess. Thank you so much and congratulations. So next up, we will have Proof of Age, and followed by another ZK project. Actually, we have 3 consecutive ZK projects, it seems. ZK Anonymous Voting System. Could you please stand by? And oh yeah, I forgot. SafeHome, could you please head on to the end of the hall to get your swags? Good job, guys.
Hi everyone. So we did an application which you can just prove that you're an adult with just a proof without revealing your age or any identical information about you. So we think simple problems require simple solutions. So, and the problem here is there are so many applications that wants to verify a user's age. So for instance, in China, there are some restrictions for minors to play video games. And also in France, there will be an implementation for age verification on pornographic sites. And there are many other applications and problems like this in real world. So our solution is with using AI, we just estimate the age of the person, and with this estimated age, we just generate a proof, and with the proof, it's, without revealing the real age, we can just validate if the person is an adult or not. And what it does, so it's actually, we firstly thought it would be better to use TensorFlow and that kind of train our own data set, but it would be really hard for the hackathon. So just for the demo, we are using an AI API, which estimates the age. And after age estimation, we generate a proof using SafeHome. And then with a Solidity smart contract, we validate the proof. So these are the challenges that we run into. So the first one is actually the models required for accurate age estimation, also the complexity of machine learning algorithms, and also SafeHome ECDSA. So this project was not our main idea, and so last night before the project submission, we switched to this idea and built this. And also future plans. So one of the future plans is to enhance the accuracy and efficiency of the age estimation model. Also, there could be some other ways to verify the real age of the user. For instance, like ID photographs, parsing the age from ID photographs maybe, or some official documents from the government website maybe. Also optimizing the ZK generation and better verification mechanism. Maybe deploying the contract on layer 2, maybe using like something like SafeHome to Cairo exports. And also maybe better privacy preserving techniques for the user. So here's a demonstration video. Here you can see the generated proof, also the blob file format of the image. And using this proof, it's possible to validate if you're an adult or not. And to increase the privacy of the user, we sent the image to the AI provider, like in a group of bunch of images to increase the privacy, because it's actually works like a mixer, like Tornado Cache. So, yeah, thanks for listening.
Thank you, Proof of Age. I think congratulations for finishing the project and a great job. I do have a question. When it comes to the circuit, how are you guys doing it? So I know you have an AI that checks for age, and how does the SafeHome like roughly looks like? What is SafeHome trying to prove and verify?
So with the age estimation using the AI provider, we sent the estimated age to the circuit, and using like less than LQ and I guess GQ functions, we check if the age is above 18, and that's how. And if it's above 18, we just return 0 or 1, like Boolean.
Okay, that makes sense. But that because the proof has been generated on the client side, meaning that I can easily like maybe bypass the AI and just generate a proof. Is that something that is possible, or is that something that you guys are trying to figure out?
We generate the proof by sending requests to backend. So we actually generate the proof in Express.js.
Okay, so that means like the user will will just share the photo, and then in your backend, which is controlled by you, generate the proof and then send over. Okay, so that the privacy risk will be on the centralized authority. Is that correct?
Kind of hybrids, yeah.
Okay, that makes sense. Thank you.
And if you're working with an AI provider, you're doing all these privacy checks and all that stuff. But how do you know that the AI provider, first of all, their AI is working correctly, and even if it is working correctly, that they're not manipulating the results on their end?
Yeah, so actually we plan to send a bunch of multiple AI providers and get an average estimated age for the person.
Yes, I saw that you are using the web, the camera of the laptop, for example, or from the phone. There are possibilities to just dupe that and send another data stream, like it's coming from the one. How would one solve that? Do you have any ideas?
As I said, for the demonstration, the photograph is just took from the web app, but in future it could be better to implement some kind of KYC stuff, like photographs of the ID card and parse the age from it, or maybe getting some official documents from the government page and uploading it to this web application, and on the front end parsing the some relevant data for it.
It's a kind of KYC light, because there is some restriction about this problem in France, China, and many other countries who restrict the age of people. The thing is, there is some maybe regulation who say just a photo is needed, and it's okay when when you move your face like this or this kind of stuff, and when you do that, it depends of the demand. So you can adapt this service about the government who do that. We know about the thing is this restriction about the freedom when you go to a website. It's not normal to make this kind of thing, but if it's really necessary, like in France, maybe it's better to use the better way to see and respect the privacy of people. That's why we get that kind of bench of people, like a pool, and mix them the picture in order to not relate to the proof and the identity. And the second thing is about we can more increase, and it depends of the infrastructure of the service. Maybe we can do something like send a fake data, fake image in order to increase the privacy. But it will be increase the price. But this is the price of privacy, I think. So it depends of what we need to do.
How does the solution with the multiple images work? Are they all the same age with the image that you take, or so if you send 20 images to the AI and they have different ages, so how will it know the correct age?
Yeah, so for the demo, we just mocked the age data, but in a real-world application, like using something like Mixer, we can just send the photos with a random value or ID or maybe timestamp, and retrieve the response with that random value.
So the photos are, so if a person is 18 years old, all the other photos are also from persons that are 18 years old, or how, if, for example, if you send other photos that are 20 years old or 30 years old, so the AI will know which one to choose, right?
So we can just build them something like middleware, which actually takes the image and give an ID for the image and send it to the AI provider, and when receiving the response, it can just separate the IDs and the image, so it can how actually get the estimated age value.
I think just maybe I missed it, but just kind of like to follow up Salim's question. Like, so if you have multiple AI providers, one is saying this person's 18, another AI is saying it's 35, another one is saying it's 20. Like, how do you? Is it just a simple averaging, or how do you figure out which one's correct?
We just add them together and divide to the number of AI providers.
So just simple averaging it out.
Yeah, but there could be some situations where if the person is 17 or 21 or 20, and the accuracy of the AI providers might be wrong. But in future, as I said, for the demo, we just use AI provider. But in a real-world application, we would most probably prefer training our own data set and building our own AI service.
Thank you, Proof of Age. Congratulations for the project. I think it was job well done. Yep. And do remember to get your swags from the end of the hall.
For your time.
Thank you. So next up, we will have ZK Anonymous voting system and DocuMed. You guys are up after ZK Anonymous voting system. So please do stand by on the left of the hall.
Hello.
Ready to go? Okay. Good morning, judges and members of the audience. My name is Yun Lim, lead for Team Cabbage, and I'm here to present to you our hackathon project. ZKP-A voting, or better known as Zero Knowledge Proof Anonymous Voting. Getting right into it, let's first go over our problem statement, digital voting. Traditional voting systems are insecure and open to alterations and faults. We believe with blockchain technology, this issue can be resolved. A secondary issue surrounds the nature of voter turnout reaching all-time lows at present. We believe that citizens need some form of additional incentive to voting, and in a sense, participating in democracy, of which we can subsidize with crypto rewards. We see this as an outlet for limitless potential. Our solution? Introducing ZKP's an all-encompassing voting app built on the blockchain that enables users to view their past history. I'll click one more time. Access their crypto wallet, vote in events and elections, accessing their Cabbage coins, and so much more. Briefly, ZKP's project structure is built into three main components. The first component involving front-end, utilizing React, JavaScript, Tailwind for styling, Redux for state management and login. The second involving the Express and Node.js, managing the API calls. And lastly, the third component, built in Solidity, where we have deployed all of the contracts on the blockchain network, Truffle, running Ganache to interact and test locally. Moving on, we're going to head into the live demo. First, if we try and see to attempt to vote on the application, zoom out. Control Shift minus. Why you zoomed in, my guy? If this could be shown. Does this have to do with the streaming thing?
What were you trying to show, actually? A bit too much? Let's pause it. Let's give them a bit of time to figure out some technical issues. I hope everyone is okay with that. Any Windows expert in the house? Okay, I think we got some Windows technical expert over here. Lovely. I'm glad it got fixed. Thank you.
Thank you very much.
All right, let's continue.
If we try and see that we want to vote for something, we're unable to because there's currently no present. So if we move towards we can actually interact this with a dashboard. Go to the next tab. Here we can actually add candidates to vote for. This is actually connected to the blockchain network. We can show you the server.js files later. But let's add Billy. Do you want a name to add to this? Okay, add Sam and add Najib, I guess. Add candidate, add Najib. And if we actually refresh on the original page, you see now it's updated to make the fetch request, but this actually also updates on the blockchain network. If we try and vote, please click one of them and continue. You'll see that we aren't able to vote because we do need to log in. So log in, create account, register. Just do like billy@gmail.com. Password 123, 123. Cool. Now log in. Now we come back and we attempt to vote for, let's say, Billy. We'll be greeted, we do need to attach a wallet to our profile section. Moving to our profile section. It displays multiple information such as voter history, crypto wallet, but let's actually add a crypto wallet. This is a test wallet that we've been given by the Truffle Pro. No, you added an A, my guy. So we successfully added a wallet, and now we'll be able to vote for the candidate. Billy, continue. Vote for Billy. If we try and vote again, you'll see that we aren't able to because this actually verifies. And then go back to our profile section. We should have updated one cabbage coin and scroll down. If you click the view history, you'll see we have our voter history. Yeah, cool. Jump back to slides. And with that, we're done. We can enter the question section. Go next.
Okay, thank you. So, are you done? Thank you. Thank you, ZK Anonymous Voting System. Interesting and great project. Congratulations to your team for winning this project. I got two quick questions. Number one, I noticed that when you are creating the candidate list, you are not transacting via MetaMask, or you're not transacting via like a wallet, because normally we need to accept transaction and we need to sign it. So how are you doing that? Like, are you actually sending it to the blockchain, or are you like, how are you managing that?
So actually, this is something that we're planning to implement feature through MetaMask. But for now, we're just using the Truffles providers like a ton of different wallets.
Okay.
That's the address that we're utilizing.
So that means you have like kind of like you have your private key in there, and then you sign it, and you just use like Ganache, and you throw everything to Ganache. Yeah. Okay, that makes sense. Okay, one more question by me will be on the ZK side. So which part of it is zero knowledge, and how do you implement zero knowledge?
So how the zero knowledge work is that so every time a user wants to join a voting event, a secret and a nullifier will be generated for them randomly, which is just a random number. Okay, so using these two random number, we will generate one the commitment hash and two the nullifier hash. Next. Okay, so so the voting process is actually a two-step process. So the first step is to submit a commitment hash when the user registers into the voting event. And the second step is to when the user want to actually make a vote, what they will do is that they will have to submit a nullifier hash and a proof. And what these two values will do is that it will use a zero knowledge proof to prove that the commitment hash that we have entered earlier. So this is to ensure that the user is voting and is already registered in the event. Now, because we are regenerating a secret and a nullifier for every voting event that they join. So what if a user says that they lost their secret and nullifier for some reason? Then we will have to regenerate for them. And this is where the user hash comes in. So what we will do is that we will put the user hash into the blockchain as well. This is to prevent the user from re-registering into the voting event again, and to prevent them from voting twice.
Thank you for the quick explanation. I got a follow-up. Sorry, just a follow-up. So now you mentioned that now you're using nullifier and commitment hash. That makes sense because they're all hashed, they're all private. But at the end, like the user action when they submit the transaction is from an Ethereum address. So that part is probably not private. So is that something that you're thinking of making it private, or you're happy with that kind of privacy?
Okay, so the user hash I'm referring in this case is not really the Ethereum address, but rather like, let's say your IC number hash, and then it's just some random number. It's not like your Ethereum address.
Yeah, because at the end of the day, you need to transact to the blockchain, and you need to like have ethers to send funds, and that part is not private.
Okay, so in that case, right, we actually are not making the user pay for the what. Instead, we will have like a master account which will pay for all these transactions.
Okay, that makes sense. Like a relayer. Okay.
And you mentioned you're having the system reward votes. Is that
in the sense that so actually all of the transactions that you saw were occurring on the blockchain. So what occurs when a user votes, we actually mint one cabbage coin. The equivalent would be if we were to give this to like the government, they would mint their own form of coins. And this opens up like endless possibilities in the sense that governments can reward their citizens for doing certain tasks. It's sort of from a subsidy through these coins.
And have you thought about the consequences of like incentivizing people to vote? Because then, you're essentially giving them money to vote, and that might affect the sort of correct reasons for them to want to vote.
I mean, arguably that's already occurring in the form of offering certain benefits and rewards if you vote for a certain candidate. But the main thing is that regardless of who you vote for, if you do register a vote, you get a coin. Everybody gets the same coin regardless of who is what.
And have you done any kind of like more thought on kind of having a system to see who would be eligible to vote? Because in this case, as long as there's any address, they can vote.
In terms of this, it requires two main things. Because what you couldn't see, we didn't have time to implement, is a form of IC checking. So we will be piggybacking off the government's own database for their IC to verify if they're able to vote or not. And the only difference is that this platform allows you to attach your crypto wallet to allow for the voting to occur. And it allows for digital voting, which, as you know, if you use regular systems, you might be able to alter the results. But through a blockchain network, these things tend to be much, much harder to alter.
Sorry, just a quick comment then. I guess that's a slight sort of thing to consider, because if you do it on a public blockchain and everything's completely public, you're tying your wallet address to your IC essentially, and then the government knows how much you have and so on. Whereas if you were to do it in a permission chain, let's say some sort of government coin, then it may not be as decentralized as you'd like, and you'd then have to trust that the government's managing that coin, that chain properly.
The alternative is to utilize another coin. It's just we were interacting and we were attempting to create our own coin just for this project.
Yeah, so you will solve the voter fraud with the database from the government, as you said, right? If I understood that, because you can use, for example, like it's also used in normal voting systems, fake IDs and whatever, to create your own identity, and then also with automated system you could create thousands of identities and
the main issue we're trying to solve in terms of digital voting is that there is no real transparency if you were to do it by regular standards. Through an open blockchain, everybody will be able to verify that the results have not been altered, that the results on who's voted for what and how many votes per candidate are there. That's a very contentious issue in lots of countries in terms of voter fraud on the numbers and who's actually getting elected. So we believe that through the transparency and security of a blockchain network, we'd be able to validate a sort of voting system. And the secondary issue is just an incentive program to get more people to vote, because a lot of people are not voting when they can.
Thank you.
Thank you very much.
Thank you, Team ZK Anonymous. Voting system, great project, and do remember to collect your swags at the end of the hall. Next up, we have DocuMed, and could Digital Asset Protection Inheritance Team Digital Asset Protection Inheritance get ready on the left of the hall. In the meantime, quick reminder: ZK Dompet is next, followed by after DocuMed, Digital Asset Protection Inheritance will be next, and ZK Dompet, NFT Music Player, and Opacity. And that sums up our presentation for today.
Okay, before the next group, I have one question. Do you guys feel hot? A little bit, right? Or cold? Hot or cold? Anyone feel hot? Raise your hand, please. Thank you. No. Okay. You can feel cold. I'm okay. Okay. Anyone feel cold? You, okay. We have our consensus, so majority wins.
Test mic 1, 2. I shall begin, or I just start? All right. Okay. All right. A very good, I would say, afternoon to all the fellow judges and also my friends here. And let's just quickly put yourself into this imaginary scenario. All right. So this is you. All right. You're a university student like me, and you're studying abroad. You're far away from home, and you're alone, unfamiliar with your surrounding. All right. So here, this is your home, your comfort zone, and you stepped out to pursue your university degree. All right. And here's the scenario 1. Right. In this scenario 1, you feel a little bit sick. And then what do you do if you feel sick? You go to the clinic. All right. So you're feeling sick, but the clinic is a new clinic to you. Like you've never been to it before. So you need to fill out a lengthy profile filling process. That is what happens when you visit a new clinic, right? And you need to assess by the doctor without prior knowledge of you. You might have allergies, you might have preferences. So these are the types of problems that you need to face when you're first visiting a new clinic, right? Let's skip on to the second scenario. Okay, what if you are somehow unconscious? Maybe you met with a car accident, all right? Maybe you're bleeding, all right? Or maybe you just fainted, all right? And then you can't really tell the hospital or the doctor about your allergies or your blood type even, right? So that the hospital doesn't have any personal information of you, and it will cause delayed treatment to your emergency, right? And that's very bad for it if you're unconscious speaking. So these two scenarios can actually solve with DocuMed, which is what today we are presenting. A decentralized application for storing medical records that can be accessed by everyone while remaining maximum privacy. And how does it work? So let's say, for example, in this scenario 1, everyone will be using DocuMed, the clinics, hospital, and you in particular. So in this scenario 1, the same thing happens. You feel sick. You go to the clinic, you just connect your wallet, sign the transaction to approve them to view your profile. So it doesn't have to have a filling process. You get instant medical records for the clinic as references for them to give your prescriptions accordingly if you have any allergies or such. So you can quickly assess and you just get your medicine and you go back, you can rest. You don't need to waste a lot of time there. And in the scenario 2 where you're unconscious, you can't really connect your wallet and scan, right? Because you're unconscious. So what you can do is they can actually activate an emergency access so that they can authorize themselves to gain your personal information. How does that work? Is by scanning your fingerprint, right? And this can lead to immediate treatment where you will be prompt with better healthcare and also like, let's say your blood type is special or you have a special allergy. But we're going to talk about the game theory about that because it might exploit from the hospital side. So how does it work? Actually, we're using the soul-bound tokens, which is SPT. And how does it work is by linking your government issue identity card with that, and it's a only one-time scenario. So you just link it one time, and you don't need to link it anyone else. So you can't duplicate your accounts. So here are the problems that we are solving, and basically the solutions that we provide. So the fragmented data is a lot of data. You might have some of the data medical records on this at this clinic, and you might have some at the others. So by using Polygon chain, it's publicly accessible. And for privacy and security, we use a lot of advanced consensus algorithm, and provide high security. As for the interoperability, we use a standardized EHR, EMR, PHR. These are the standard medical records format so that it can be accessed throughout the worldwide. It can be accepted worldwide, right? Using this, and it uses fast transaction because it uses Polygon, and the patient access is user-centric because you hold your own information. You authorize the information to the hospital if you want them to have access to your medical records and personal information. as for the cost, it's low compared to traditional methods because traditional electronic medical records can be expensive, their system to maintain. So here's a demo of our app. So let's say get started. So this is a mobile worksheet. You can actually connect your wallet and log in, or you can also click the new sign up, which you'll be prompted with a username and the password. So after that, you get the secret backup phrase. So this is the seed phrase. It's basically like a MetaMask. Everyone here, I think, is quite familiar with MetaMask, right? So this is basically the first phase of MetaMask. And after you set it up, it's actually not fully activated yet. You need to pay a visit to a hospital or clinic for your first activation with the SBT. So right now, it will be prompt with the confirmation. If you want to connect with that hospital, you want to show your personal information to them. You can also remove access after that if you don't feel like sharing with them anymore. And then here you can see a lot of details, which are your past medical records, your past treatments. Maybe you visited them and the doctor's note would be written down, and what kind of symptoms and what kind of method of prescription they are giving. It's 5 minutes, but I'll let the video run. So this is your personal profile with your personal information. You can also view it. And after that, you can that's log out. And this is the web page view. So this we are using from the hospital or health institution standpoint. So it's the same process, also like the MetaMask, but without an SBT, right? Because they don't necessarily need just one. But for user profile, you only can have one because you do not want duplicate records, right? Once that is done, it's the same process. You can actually view this is the deposit, and you can get access. This is for the emergencies feature. So this is a deposit. Is basically the same as transferring anything on the Web3. And this is the emergency one. So basically, you just scan the patient's fingerprint, and then you get to see their medical history. You can update it after you have done any surgery or any updates to the patient, and you can update their treatment history. You can check their treatment history, and you can also check their blood tests, their type of allergies, all of the details necessary for a surgery to perform or a prescription. All right, so I think that's the end of the video. Yeah.
Cool, thank you. Thank you so much. DocuMed, congratulations on finishing the project. I got a question. How do you plan on linking the fingerprint to the address?
Yeah, so just now I talked about when you started to activate the wallet, it's not fully activated yet. You need to pay a visit to either a hospital or a clinic, right? So by that time, you present your IC for a short KYC and then your fingerprint. So it will be linked together with your SPT.
And just to double check, you didn't mention any ZK or privacy things in your presentation. No. So the question that anyone would ask if I have my medical records on chain, like does that mean everyone in the world can see my medical history?
It would be protected only to be accessed from your account, unless you grant permission to said entities or institutions.
So where is the data stored?
It's stored on the Polygon blockchain.
So the data is stored on the Polygon blockchain, but if someone were to look at that particular address, then they wouldn't be able to see my records?
You'll be protected by a cryptography algorithm.
Okay.
But we might consider using ZK as well, like in the future.
Okay. And you mentioned a deposit. So can you describe how that deposit thing works again?
Because I didn't talk about the game theory, right? Because the health institution has the access to override your personal information, right? They can just get your fingerprint and they can see your personal information. So once actually they done that, simultaneously, I would say their tokens in their wallet would be locked up a small portion, right? And after the patient is conscious or after the patient is able to access their own wallet, they'll be able to sign a transaction to approve the locked amount to be transferred back to them or to be transferred to their personal account. So if they decide to transfer back to their personal account, which is when they think I think the action of the hospital is in the wrong. They want the transaction to be benefiting them, so that they would need to sign the transaction to transfer back to them, and then this wouldn't complete the transaction first. It would prompt the hospital to provide evidence saying that the hospital is in the right in doing so of accessing your personal information because in a case of emergency, so that all of the stakeholders of the token would be able to vote on that, and then the winner will get most of the amount, and all of the voters will get a small portion of the tokens as well.
So, so if I was unconscious and I was sent to the hospital needs to pay money or deposit some of their own funds to be able to treat me?
Yes, correct. It's a emergency feature that they actually need at the beginning of using the system.
And then to arbitrate between the hospital and the patient, there is some sort of voting system where community members would vote on whether the hospital is right or the patient is right.
This only happens if the patient thinks that the hospital is in the wrong. If the patients woke up fine and they decide to think, if they think that the action of the hospital is in the right, then they can just sign the transaction to have it transferred back to the hospital.
Right.
I just had the question about security, but I think you asked it. So the data that you store is encrypted. So that was the solution, right? Thank you.
Thanks.
Okay, thank you so much, DocuMed, for your presentation and for your project. Congratulations, and do not forget to collect your swags at the end of the room. Next up, we will have digital asset protection inheritance, and could ZK Dompet head to my left to prep up, and because you guys are next. And after ZK Dompet, it will be NFT music player and opacity.
Test mic. All right. Hello, everyone. My name is Yongming from Daphne. And before I begin my pitch, imagine this. You are an entrepreneur working so hard for your entire life for a digital empire. And suddenly, everything gone. You die, and your private key goes with you. And everyone knows that private key is so important in our life for all the cryptocurrency holders. Because if you lost private key, everything lost, right? So that's the only access way for you to access your assets, digital assets. So there is no means for cryptocurrency holders to store their private keys and pass it to the next generation. So what is the real problems that we are trying to solve? First, lack security and privacy. Why lack security and privacy? Because if you are a millions worth cryptocurrency holder, you won't just give your private address, a private key to your next generation, right? It consumes a lot of breeze. And the second one will be tedious inheritance documentation. You need a lot of structured documentation to teach the executor, which is the view executor, to pass your asset. And the last one will be non-transparent assets transfer. There is no way to track how the assets is transferred to your beneficiaries. Right, so to date, 24 billion worth of cryptocurrencies lost because of mismanagement of private keys. And we are trying to solve it using DAPNI, which stands for Digital Asset Protection and Inheritance. Right, so what's DAPNI do? We create view and add beneficiaries, and then we automate the asset transfer by trusting the validators that we have in the system. Right, so let's look at the current process of inheriting digital assets, which is the view. So the client goes to find a lawyer and provide them the private key. And the private key will be stored in the plain text in the view, physical view, and then will be stored by lawyer and client. And after death event, the family member will find the lawyer and extract the private key from the view, physical view. And the executor will need to have a technical background to know how to access the digital assets. And how DAPNI works. So we provide a H3S encryption when the client finds the lawyer before the death event. And then we use H3S encryption to create a sort and random key here. And then we store it in IPFS, and the view only store a random key instead of your private key. After death event, family member find the lawyer and get the random key from the view. So we need the validators here. So Dapney server will prompt a request for the validators to sign transaction and then get the approval, and then we will trigger the asset transfer automatically to the beneficiaries. So this is why Dapney works. We provide privacy, security by using the H3S encryption, and also the convenience by using a UI, easy access UI. All right, next one is the Dapney user journey. I will go to the demo right now. So you can see here, from here you can connect to your MetaMask. All right, connect using asset owner. All right, start to create the view. You just need to put the validators and the beneficiary address, and then the percentage, submit. Okay, the smart contract is deployed, and the random key will be provided here. So it will be stored in the view later. And this is how the law firms or the inheritance responsibility notice to activate the view. So they submit it. Right, and we need the validators to validate our view. Yeah, that's it for the demo. Okay, next one will be the tech stack. So the tech stack is using the blockchain and then the smart contract here. We use a client, React, and Nest.js. And this is the market size that we found in our Malaysian market, which is 3.5 million from the Etherscan. And then the key partners where we need here is the bank institution, financial institution, law firm, and Etherscan, because we need to validate how the digital assets is transferred to the beneficiaries. So we need Etherscan here as well, and the legal body side. All right, that's all for my presentation. Thank you.
Thank you so much, Dabney. It's much easier to say compared to the full name. So thank you so much. Congratulations on the project. And I got a couple of questions. And so right now, what are you using for IPFS again?
IPFS is storing the sort, which is used to encrypt our private key.
So you're storing the sort in IPFS, which actually IPFS is public. So basically anyone with enough effort is able to retrieve the sort. Is that what you're trying to say?
Yeah, it's okay. So the private and the secure part is the view here. So we want to avoid people from accessing our asset transfer process by just using a private key. And we need to limit them using the random key here. Yeah, this is how we separate the responsibilities of the key.
All right.
So that it's kind of like decentralized responsibilities.
All right. And then what is the whale? Is it a smart contract or is it something that's stored by the owner?
Sorry?
What is the whale? Like who stores the whale? Is it stored centrally? Is it stored decentralized in a blockchain, for example?
The view. Okay, the view will be stored in the smart contract, which will be deployed in the Ethereum blockchain later.
So that means if I have the time, I can go to IPFS to get the sort, and if I have time, I also can go to Etherscan to also get the random key, and then I could somehow do a bit of easy brute force, and I can encrypt that thing.
Okay, so here's the thing. The random key here, we are not storing in any server or any digital system. We are storing in the physical view. So this is the physical view that normally people go to a lawyer firm and then ask for the physical view. So this is like kind of separate it into a physical view and combine it with the current solution. Like I want to pass some estate to my son or daughter, so I need to go to a law firm, right? So we can just give an extension for the user to just apply the cryptocurrency inheritance here.
Cool, thank you. Thank you. That makes sense. And how much of this you were able to complete? Like you also mentioned the validator part. Do you manage to like finish the validator part?
You mean how
during the hackathon? Like how much were you able to complete? It seems like a lot of things that you have doing.
Okay, so actually the problem here, the bigger challenge is to think of how to cooperate with those entity bodies here, like bank and also law firms, because we need their trust to use our system and the service.
Oh no, I mean code-wise, like how much were you able to finish?
Code-wise. Okay, so the code-wise, because I am quite familiar with the UI, and also I have my own UI templates, so I can quickly generate the UI templates and just apply the logic here. Okay, so here's the thing. Smart contract is not my specialization actually, so it requires a lot of effort here. The solution is working, but without a lot of testing, I would say. Yeah.
Thank you, that
Just
makes
enough
sense.
for demo.
And so for the validators, who are the validators exactly for a specific will? Like, how do you decide on who becomes a validator and what's their exact role?
Okay, so the validators can be separated into law firm if the users, if the customers trust the law firms or they trust their parents or their family members, they can set the validators in the create view here. Yeah.
So basically, a validator is someone who kind of signs off on whether that payment gets transferred.
Yeah, they are like the approval of the asset transfer process.
So if it's kind of like a multi-signature wallet, and if you have a few validators that sign off, then transaction
I
goes
think the
through.
logic is the same as that.
Thank you, Dabney. I think that's all we have. And congratulations on the project, and do remember to collect your swags at the end of the hall. Next up, we have ZK Dompet, and after ZK Dompet will be NFT music player and followed by opacity. So NFT music player, would you mind heading to the left of the hall to get prepped up?
Can we start? Okay. Kevin, can you start? Hi everyone, it's Pia. Today we will introduce our ZK Dompet. Before we start, let's imagine one situation together. What if you should do a very important and heavy transaction that needs a privacy? And what if you have to use a public network? This situation usually happens if you are a very big organized group and that needs a high privacy and also multi-parties agreement. So what solution can we choose now? You need a multi-sig wallet. We also have a good solution like Notice Safe. But owners of the multi-sig wallet can be tracked and traced because it's on-chain, right? Then you want a private transaction. We also have options like Tornado Cash. But the problem is we have to use only fixed deposit amounts based on the pool size, and also now have an issue related to the regulations. Then what solution can we use when we face that kind of situation? So here comes our ZK Dompet. ZK Dompet is a multi-sig wallet that provides the private ownership. And what ZK Dompet can do? ZK Dompet doesn't link each owners to the multi-sig wallet address, and we use the ZKP of the owner's identity to submit the private transaction. Because also our wallet is account abstraction that uses the EIP 430, so it is safe. So I will explain how the ZK Dompet works. Let's see the overall flow. First, the front end generates the input.json for the circuit UI. And the circuit returns the proof. We will explain this later slide. And we aggregate the proof and send the proofs to the relayer. And the relayer helps enable us to do the private transaction. By using this relayer, we can able to deploy or execute the transactions like a normal wallets can do through the smart contract. After pass the verifier and multi-wallet contract, you can able to execute it. Let's explain how does our circuit works. Our circuit contains the two main logic. First, ECDSA verification. This ensures the authenticity and the integrated digital message that user already provided through the front end. And second is hash pub key comparison, this part. And this part is compare the generated public keys hash to the public key hash that user already provided. And now let's watch our full demo video. You can connect your wallet and then create a wallet, and you can put a name on it, and then now provide a Mumbai. We already deployed it. And then you can set the owner's information, just like Notice Safe. Something like that. Yeah, because I'm getting the wallet address. You can set the threshold and then review it, and then you put your private key for now, and then sign a message, and then submit it. Then, yeah, this is a proof is generating, and then this input.json, the front end is generating input.json to the send to the circuit, and then make a wallet. Now you can do the lot of transactions. I give the example of transfer. I send here to this amount of Matic. So I'm sending the transaction, and we can see this ID as an auto task. And then we can grab this, this data from the auto task. And then when you go to the poly stand, then click our transaction, you see the transfer from here to there. This is a real layer, so we can make a private transaction. And this is the destination that we already put as an input. This is the value. All number is, yeah, success. So this is some more, yeah, transaction is success. Can we move on? Yeah. This is the more information about the ZK dompet. We use the Circum and Solidity, OpenZeppelin Defender, Next.js for our demo. And our contract is already deployed in the Scroll and Mumbai. And then we also have a future plan for improvement, of course, supporting the multi-party signer through aggregating the multiple proofs and make it as a more secure way. Thank you.
Thank you, ZK Dompet, for the presentation, and congrats on finishing the project. It seems like it's a lot of things has happened in your project. Could you explain a bit, like what are the hardships that you have faced?
It depends on the people because we take parts, different parts. And my side, it's very hard to generate the input.json because there's not much docs about how to generate the input.json. So we had a brute forcing. This input is correct or not, and then we ask about the identity Telegram group chat about how to generate this. This is wrong, you can see the error. So this kind of help that we get through this hackathon period, and then yeah, we successfully find the right input, how to generate it through the efficient ECDSA repo that has a task.ts file, and then we reference this kind of mathematical algorithm to make a right input.json. This is the hardship that I faced as a front-end side. Maybe.
I can see a lot of hardships among in your team.
Yeah, so for the circuit itself, what I face hard is just basically generating the Z key. Because the circuit itself is very big, it needs a lot of memories. And I used a M1 Mac, which even when you generate the Z key, it keeps on failing because the circuit itself is too big. And generating the Z key itself is too big, but it's just a one-time step. And I think for the generating proof, we keep on facing problems like facing wrong ECDSA, wrong assert. So now that's the hard problem for the Circom, but we are able to fix it. And yeah, I guess that's all for the circuit.
So one question on the, maybe you can have a share. So one question on the usability of this wallet. So if I understand correctly, from the main blockchain, what you see is someone depositing into a relayer. So there might be 100 people that deposit, and then from the main chain, you only see one address, right? Is that correct?
Yes, correct. So of course, as you imagine, someone needs to deposit funds to relay. when we actually send from the front end, it's actually we just sign it, and the relay layer only allows certain API key. So in this case, only the user through the front end you can submit to the OpenZeppelin's relay layer. And if you look into the detail, actually at the end of the day, the last wallet that receives the fund receives from the relay layer and not the initial user. So it's hidden that way.
So from a usability point of view, let's say I've deposited funds into this ZK dompet and I want to pay someone. How do I know that the transaction has been made? Because from all I can see anywhere is just that my funds has been put into the relay layer, right? So how do I know when my transaction has been successful? How can I validate that this is the amount of balance I have?
Oh yeah, so I mean, if you were the creator of the wallet, right, you would know, I mean, during creation, you would know the created multisig, that's number one. And then you can actually check in the transaction, you will actually see the relay layer submits a transaction to the multisig. Yeah, and then within the multisig itself, you will see the final relay meta transaction.
So are you saying that the multisig address is available for other people to see? Like they can see that address?
They can see it, but they wouldn't know who you are.
Okay.
Because it's being relayed. Yeah.
Okay, so there's like a step in between to kind of like camouflage my
exactly.
transaction.
So the relay is also apart from circuit is like the air gapped it in some way.
So you still need some mixing involved, right? Because if there's only one transaction, then within that one day, then if I know that only one person has made that transaction, I know who that person is, right?
You're absolutely correct.
So it's still a mixing
you need some
kind of
sort of
solution.
mixing because I mean, if you have access to relay layer, you can sort of narrow down. Yes.
So is there a difference between this and let's say Tornado Cash, for example, or Aztec?
Sorry, the biggest part difference is we're using the account abstraction. So it's a wallet, not just mixing the transactions. So you can actually, there should be a much more use cases rather than the Tornado Cash or just a network like Aztec.
Okay, so if I have this wallet, then would I still be able to interact with any DeFi apps directly without any kind of interface in between?
Currently, the workflow that we have currently relies on the relay layer and to relay whatever transaction call you want to submit through it. So it would be able to support most, if not all, transactions.
So the relay can still interact with any contracts out there?
Oh yeah.
Okay.
So this kind of part is our in the future improvements.
I saw somewhere in the presentation that you put the private key in before the ZK circuit.
So currently we can. I didn't find a way to generate the private key through the signature, the wallet itself. So this is also the future improvement for my side. But because I spend a lot of time making the right input.json, so the best way to make it working demo is just put the private key inside. And also it's if the user can believe us that we are not storing the private key, is much safer way. Yeah, so, but it's also a future improvement. We will create this kind of hash pub key and the signature, something like the input JSON file through the wallet connection. Yeah, this is the part that I look at.
Yeah. So for the private key itself, right? The private key is inputted through the front end, but actually the things needed for the circuit itself is just the transaction call data, the RNS, and also the pub key. So to generate all four of these, they have to pass through their private key. It's the only way to generate all those four inputs. So in some way, right? So let's say there's a different user generating a proof, it will only based on their private key.
Thank you so much for explanation, and I think time's up. Thank you so much. Congratulations on your project, ZK dompet. Remember to get your swags at the end of the hall. And next up, we have NFT music player. And last but not least, Opacity, could you please stand by because you're after NFT music player.
Hi everyone, my name is Tiong Woon, and today I'm here to present to you on my hackathon project, the NFT music player. So music listening is huge. In 2021 alone, the global recorded music annual revenue was 25 billion US dollars, and this is estimated to grow with an annual rate of 8.5%. The next one is huge. On average, a teenager spends 2 hours per day listening to music actively. That is to say, they are just listening to music. This is important because the teenagers of today is going to be the mainstream NFT holders of tomorrow. But the problem is, while there are a lot of marketplaces that allow me to buy music NFTs, I can collect a ton, there is actually no platform that allows me to listen to them like how I listen to my Spotify. Here's why. So first of all, music listening is an activity you do when you are doing something else. I'm sure everyone can relate to this. And according to survey, 66% of people listen to music when they are driving in a car. But the problem is, so first you get your NFT from marketplaces, but it doesn't actually provide you the user experience of a music player. For instance, if you look at OpenSea, you can actually play this music back to back, but you actually need to click on each of them after a track ends. And you can't actually do that while you are driving. Otherwise, it would be like pretty life-threatening, I suppose. So in terms of the target addressable market, we are looking at an estimated of 100 million potential NFT music listeners today. And this number is estimated to grow as NFT become more and more mainstream. So ladies and gentlemen, the solution that I built is a front-end website that allows you to play your music. So here's how it works. You need to wait for the music, for the YouTube to load. And then you connect your wallet. And then the website auto-loads your music NFTs. And bam, you can start playing, loop, repeat, shuffle, queue, however you want. So my vision for this is to actually deliver a simple and seamless music listening experience to NFT holders. So with this platform, you can buy your music NFTs and come to the platform and enjoy your music. In terms of future plans, here are two main strategies. First, we optimize towards product market fit, and that is to say, we get more and more users to come back and use the product. With that, there are a few things we can do. First is to expand the functionality. For example, we can add a queue function. Next is to expand the NFT protocols that it supports. Currently, it only supports sound.xyz, but the more protocols we can support, the more useful this becomes for more users. Third one is building on the insight that people listen to music while they are doing something else. So I think the mobile app is the best place to deliver this value to users. Last but not least is to expand the chain support. Obviously, the more chains that we can support, the more useful this platform becomes to more users. Assuming that's achieved, next we can also optimize for shareability in order to drive the growth loop. For example, firstly, what if you can invite your friends to listen to your NFTs? They come to the platform, they listen to NFTs, they get their own NFTs, they invite their friends, so on and so forth. That's how the platform can grow. Secondly, because crypto people live on Discord a lot, so if we can integrate on Discord so that your channel members can listen to your music NFTs, then this creates more exposure to the platform and hence acquire more users. That's the end of my pitch. Thanks everyone, and yeah, open to questions.
Thank you so much, NFT music player. Thank you, a great project. I got a question. So what you're trying to do is that you're trying to make sure that the music will come play one and after another on OpenSea.
No, so it's a platform that you go to OpenSea, you buy, and then you can connect your wallet to the platform, and then you can listen to it. You can create, your own playlists. You can queue, you can loop, you can repeat a song if you want. Yeah.
Nice, thank you.
So are you targeting more of the listeners or the musicians in this case?
So it's actually a self-reinforcing ecosystem because once you allow music NFT holders to actually use their NFTs in a productive way, pleasurable way, then the musicians will know, okay, actually when I create these NFTs, my listeners will be able to enjoy it in this way. then they will be more empowered to create.
Yeah. So, so it's kind of, if I can understand it correctly, it's kind of like you want to show off. This is your list of music NFTs, and only you have this specific list of music. Is that?
So not exactly like that. Although that can also be a function of this platform. So think of it this way. Before everything is digitized, we have CDs, we have music players. So you can only get CDs and play them. If you don't have CDs, you can't actually listen to Jay-Z, Beyonce. But with this, it's actually a skeuomorphic version of it. You get the NFT, it's like buying a CD, and this is just the CD player. Yeah.
But so if I'm a normal listener, I mean, I can go to Spotify and create my playlist. I can send it to my friends and so on. So what's the value add to me as a music listener that there is an NFT music player?
So this only, for this to actually be valuable to you, we need to be in a world where NFTs are very prominent. NFTs are I guess not the main, but one of the distribution channels for musicians to distribute their music. And we all know the current model of Spotify is the fact that they are not getting enough return for what they produce, right? We have the middleman, the record labels standing in between. And Spotify in itself is taking a lot from the musicians. I'm sure, this is something that people always use NFTs as a narrative for. Yeah. So we need the world to be there in order for this to actually.
So you're kind of targeting the people who are already in an NFT space, and then there is kind of something for them there that they can try something different, and then potentially musicians would then be attracted to go into this system.
Yeah.
Okay. Do you have a site running already where I can play my music NFT?
Yes, it's in the link in the dev post. Yeah.
So is it any NFT? Like, would there be any NFTs that I might have that that supports the sound XYZ? Like, would it be any NFT that supports that standard?
So you need to buy your NFTs from sound.xyz because I sort of like customize the code to detect that lah. But if you have any wish list, like hit me up, I will.
Okay. And so where is the music data stored? Like, in a server, in IPFS, or?
Okay, so this is actually just a simple front-end layer. The music data is actually stored everything is handled by sound.xyz protocol.
Okay.
So for sound.xyz, they're using Arif.
Okay, so you kind of like an interface on top of sound XYZ.
Is there a plan to also onboard people without a wallet? What could be the possibilities of that?
Yeah, so I actually thought about that, but currently I think we might not go there, so I want to sort of keep the beachhead to just NFT music holders. And here's the reason. To do that, you can go to sound.xyz and you can already do that. So they stream for that. So my strategy is not to go there, but just to attract the NFT music holders, music NFT holders. Sorry. Yeah.
Thank you so much, NFT music player. It was a great presentation, and congratulations on the project. Do remember to get your swags at the end of the hall.
Welcome. Thank you, everyone.
Thank you so much. Finally, we are towards the end. And last but not least, can we have Team Opacity get ready for your presentation?
A very good afternoon to the judges and to my fellow competitors. My name is Yongjun Fai, and today I'm very honored to stand here to represent my team and to introduce to you to our social payment app that revolutionizes the way we pay for goods and services. First of all, I will begin with breaking news. FTX filed for bankruptcy on the 11th of November after a surge of customers withdrawals earlier in the month because the company didn't have sufficient assets in reserve to meet the customers' demand. The immediate point to the news is that the current financial systems are centralized and governed by a small number of organizations. They will collect the user's personal data. This is subject to security lapses and fraud, which can result in the loss of data and also personal money.
only that, these financial institutions will also invest their investors' money in a variety of assets. Therefore, if the company goes bankrupt, they will not be able to refund the money back to their investors. Another tragic example would be Lehman Brothers. Therefore, my team has proposed a solution for the problem. Let me introduce to you opacity.
Thank you, Junfei. For the above mentioned problem, we will have the opacity, which is the solution, social payment app. We have two features for opacity. One is trustless registration, while one is decentralized. For the trustless registration, user will not require to compromise their data. Instead, they just need to link their own choice of their wallet to the app, and they can use opacity wallet. For the decentralization, user will have fully control of their own asset. Also, we will highlight the use of crypto in this social payment app. For our business model, there are two characters in opacity social payment app, which are merchant and customer. For the merchant engagement, we will provide the on-app advertising for them. Besides, they will be free of charge of collaboration fees. To engage customer in using our product, we will give them discount on buying goods and provide a convenient QR payment feature. As for the initial capital collection, we will require to collect a minimum amount of transaction fees. Thank you.
Thank you, Sakang. And now to a very simple demo of the app. So first, users will connect any wallet of their choosing. And here I'm using MetaMask. Okay, so after connecting, users will have two main ways of payment. The first one is by copying the address of the recipient and entering the payment as well as the keyword and the message. And after that, they can just click send now. And the second method is the QR transaction payment, where users can scan the QR code of the recipient from this web page. And after that, they can enter the payment amount, the keyword, as well as the message, and it will automatically be sent over to the recipient. And finally, there is a live display of the transactions that happen on the web app, and it features the recipients and the sender's addresses, the amount sent, as well as the message, and also the keyword which is used to generate the GIFs over here. The keyword and the message is used to easily identify the transactions that happen on this app. And thank you.
Thank you so much, Team Opacity, for the presentation, and congratulations for a job well done. I can't think of any questions. Probably I should pass.
So for this app, I think, I don't know if you agree, but important thing to do is to be able to sign up the merchants to be able to use your app.
Yeah, we will let them to sign a terms and condition, and the terms and condition is about to, just now I mentioned about the discount feature. So although we are provide the free advertising and there's no charging additional fees for the collaboration, they will need to have something like cashback for the customer in use of this DeFi app.
So what's in it for the merchants again to sign up with you?
Actually, there's no specific condition. You just need to give the discount and cashback for certain goods.
I mean, so if I'm the merchant, I have to give discounts for users. But what do I get?
The free on-app advertising. Yep. And yeah, we will help you to advertise your business in our app and both our social media apps.
And so if I'm a merchant that's signing up to this, then I should be someone who is willing to receive cryptocurrency.
Yes.
But so, cryptocurrency is not stable. I'm not paying my bills in Ether or USDC.
Okay, that's understandable. So we are including our built-in exchange in our app for the user more convenient to change their ETH into stablecoin, because we know that stablecoin is more consistent, so it's more suitable for buying goods.
That will be in our roadmap for the automatic conversion.
You need a license for that.
Sorry?
I think there's also the chicken and egg problem where you need a lot of users on your platform so that the advertisements are seen by the merchants. So which one? But of course you need to onboard these users and onboard also the merchants. So if you try to onboard merchants before you have users, it wouldn't be possible, and also vice versa. You couldn't onboard merchants if you don't have enough users. What will be your solution to that? How will you incentivize the growth?
We believe that crypto will only be getting more popular. So instead of the traditional e-wallet, the wallet owner, they might change to the DeFi social payment app, which will use crypto, just like I mentioned just now. They use stablecoin to buy goods, just like the Touch and Go we are using now, but it's decentralized version and it's in use of cryptocurrency. Yep. When we get enough of merchants and as I said, there is discount for users, so there will be more users as well.
Thank you, team Opacity. I think thank you so much and great work. Congratulations on finishing the project. Do remember to get your swags at the end of the hall. And with that, we have concluded all 11 teams, and I personally thought interesting panel session with guests from Etherscan.
Yeah, from Etherscan, Ethereum Foundation, and Coordinate.
Thank you. So you definitely want to look forward to that, and afterwards we will have